Welcome to basic thermodynamics class. So we are discussing the chapter 2, that is the thermodynamic process. So in the chapter 2, till now we will completed up to adiabatic process, and yesterday's class also we discuss about some problems related to the adiabatic process. So in this class also we will discuss some more problems related to the adiabatic process. The formulas we studied in the yesterday's class means, so first, what is the adiabatic process? So, what is the relation? What adiabatic process can be represented by the equation PV power gamma is equal to constant, where PV is a pressure, volume, and gamma is an adiabatic index or adiabatic constant. So, which type of a process is called an adiabatic process means we can tell as a process in which there is no heat energy is transferred to or from the system. So, there is no heat transfer to or to or means in to or from the system, means inside giving and outside. So, with no heat transfer Q in and Q out, Q is equal to 0 is called an adiabatic process. Adiabatic process. So, yesterday we discussed about the expression for the work done during the expansion process and the compression process, and the some relationship between the specific heats and the constant. So, first we have to write before going to the doing problems. So, just we will narrate the formulas what we did yesterday's class. So, work done during the adiabatic expansion. So, see these are some both the problems are there in expansion and the compression. So, if you consider the compression, the internal energy increases. If you consider the adiabatic expansion, internal energy decreases, because here the according to the non-flow energy equation dq is equal to w plus du. Here the dq, there is no heat transfer is take place. So, for the adiabatic process q is equal to 0 means, so the net flow non-flow energy equation can be written as a 0 equal to w plus du. So, w is equal to minus du. So, for the adiabatic expansion the work done means the internal energy decreases. So, opposite to the expansion, the compression result. So, it is noted that the adiabatic compression in the work done in the adiabatic compression, the internal energy is increases. So, work done during the adiabatic expansion, work done during the adiabatic expansion is W is equal to P1 V1 minus P2 V2 by gamma minus 1, where gamma is the adiabatic index, or we can write this equation as Mr T1 minus T2 gamma by 1, because PV, we know that the ideal gas equation PV is equal to MRT. Here it is a P1 V1. So, we are writing the equation as a P1 V1 is equal to MRT1. Like similarly, P2 V2 is equal to MRT2. So, substituting these two values in this equation, MR is a common. So, you take the MR common, bracket open T1 minus T2, and the denominator remains the same. So, this is the work done during the adiabatic expansion. So, this is the internal energy decreases. In this, the internal energy decreases. Coming to the adiabatic compression, work done during the adiabatic compression, it is a negative sign. So, W is equal to P2 V2 minus P1 V1 divided by gamma minus 1, or we can write as a MR T2 minus T1 by gamma minus 1. This is the work expression for the work done during the adiabatic compression process. Next, relation between P, V and T in adiabatic process. So, when you tell that the given the equation that PV power gamma is equal to constant, PV power gamma is equal to constant. If it moves from the state 1 to state 2, between the two end states, we are writing the relation between PV as a P1 V1 power gamma is equal to P2 V2 power gamma. P1 V1 power gamma is equal to P2 V2 power gamma. Like that, this also the relation between the temperature and pressure. So, in this equation, we are removing the volume and substituting the T. How we will substitute the T? We know that PV is equal to MRT. So, we have to eliminate the V. So, we can write this V is equal to RT by RT by P. So by simplification we can get T1 by T2 is equal to P1 by P2 gamma minus 1 by gamma. So this can be write in any form. You can bring this power also this side. You can write T1 by T2 is the power gamma by gamma minus 1 is equal to P1 by P2. By eliminating the V by using the ideal gas equation, we can write the relation as T1 by T2 is equal to P1 by P2 whole power gamma minus 1 by gamma. So we can write this equation in any form. By bringing this power to this side, the power comes like a gamma by gamma divided by gamma minus 1. Or we can write this equation as a T2 by T1 is equal to P2 by P1. Here I am exchanging the numerator and denominator in both sides. So, can write this is equation also T2 by T1 is equal to P2 by P1. So, depend upon the data given in the problem, we can modify this formula, but it come like a T1 by T2 is equal to P1 by P2 whole power gamma minus 1 by gamma. Like that, the relation between is here it is a T and P. Now the relation between T and V. T and V. Simply in this equation we are removing pressure. Simply we are removing the pressure and writing the equation in terms of a temperature. PV is equal to mRT. So we can write P is equal to RT by V. By substituting the value here, we can get the by simplification. By after simplification we can write the equation as a T1 by T2 is equal to V2 by V1 whole power gamma minus 1. If you want to bring this gamma to this side, then the equation becomes T1 by T2 whole power 1 by gamma minus 1. If you bring this power to this side means if the power if power comes to left side, it becomes a 1 by 1 divided by gamma minus 1. 1 divided by gamma minus 1. So, by combining these equations, we can write the three equations like a V2 by V1 whole power gamma is equal to P1 by P2, T1 by T2 whole power gamma by gamma minus 1. So, these three formulas are very important, and in the 1 marks problem or the 3 marks 1 mark question and 3 marks question also they will ask write the relations between P, V and V and T, P and T, or individually they will ask for the 1 mark question. So, you have to remember this equation. So, if you don't remember this equation, simply remember the first equation. You know the first equation is PV power gamma is equal to constant. So, you know that from the first one two statements P1 V1 gamma is equal to P2 V2 gamma. So, in that if in the problem they asked write the relation between T and V means eliminate P by using the ideal gas equation PV is equal to mRT. Then simplify, we will get the equation T1 by T2 is equal to V2 by V1 whole power gamma minus 1. Similarly, relation between T and P also eliminate V and simplify, we will get the relation between T and P also. P1 by P2 is equal to the relation between P and T is P1 by P2 is equal to T1 by T2 whole power gamma by gamma. If you remember this whole equation, if there's write the relation, if you remember this one is very important. If you remember this one, if you remember this, if they ask write the relation between P and T, you can write this one. In the question they ask write the relation between P and V means this one. P1 by P2 is equal to V2 by V1 whole power gamma. If there is a relation between V and T, see V2 by V1 whole power gamma is equal to T1 by T2 whole power gamma by gamma minus 1. Here the gamma and gamma are cancelled. So, here same equation we will get V2 by V1. If 1 by gamma comes to this side means it comes to numerator gamma minus 1 is equal to T1 by T2. So, for doing the problems you have to remember this relation between P, V and T and the work done during the expansion process. So, work done during the expansion process is a P1 V1 minus P2 V2 by gamma minus 1 or MR T1 minus T2 by gamma minus 1, and there is a relation between the gamma and the specific heats also, gas constant also. So, Cp minus Cv is equal to R, and gamma is equal to Cp by Cv. Gamma is equal to Cp by Cv. By using these two equations, we can calculate the Cv value and Cp value. So, Cv is equal to R divided by gamma minus 1. Cp is equal to gamma R divided by gamma minus 1. So, just we will do some problems based on the adiabatic process. So, these problems are important for the 5 marks. The first question, certain quantity of gas occupies a volume of 0.4 meter cube at a pressure of 120 kilonewton per meter cube and temperature 25 degrees centigrade. The gas is compressed isothermally to a pressure of 450 kilonewton per meter square and then expanded adiabatically to its initial volume. So, what's the given in the problem? They given it is expanded adiabatically, means adiabatic process, adiabatically expanding means the work done is equal to P1 V1 minus P2 V2 by gamma minus 1. So, in the question what they given the data, first read the question carefully and identify what is the process and write the given data and write what they are determined and write the formulas related to the process. Occupies a volume of means 0.4 meter cube. So, V1 0.4 meter cube, pressure P1 they given directly as a kilonewton per meter square, P1 120 kilonewton per meter square, temperature 25 degrees centigrade, T1 25 plus 273. So, the gas is compressed isothermally. Here the given the combination. So, here they given the combination of isothermally also. Both they compressed isothermally. Here the pressure is decreasing. Is isothermally means two process 450 kilonewton per meter square and then expanded adiabatically to its initial volume. So, this is the three process here. 1 to 2 is an isothermal process, 2 to 3 is an adiabatic process. So, what they asked, heat transfer during the compression. The change in internal energy during expansion. So, the heat transfer during the compression means the compression takes place in the isothermal process. So, you have to calculate the heat transfer at a constant temperature process and change in internal energy du. Du is you have to calculate, du is equal to minus dW. So, minus dW, you know that the W is equal to is the expanded form, W is equal to P1 V1 minus P2 V2 by gamma minus 1. So, whatever the W we got, simply we will put minus, we will get the internal energy. Next, the mass of the gas. So, you have to calculate the mass of the gas, they given the Cp value and the gamma value. By using these two values, we can calculate the Cv value. So, we know the relation between Cp, Cv and gamma. So, the adiabatic index gamma is equal to ratio of Cp by Cv, So, first write the given data. V1 0.4 meter cube, P1 120 kilonewton per meter square, T1 25 degrees centigrade. So, it converting into the 298 plus 273 means 298 Kelvin, P2 450 kilonewton per meter square. Consider an isothermal process. The given is it is an isothermal process for 1 to 2. So, isothermal process means the constant temperature. Constant temperature means P is inversely proportional to the volume. So, according to the isothermal process, constant temperature process, P1 V1 is equal to P2 V2. So, in the data they given the values of V1, P1 and P2. So, the remaining term is the V2. So, we have to calculate this V2. So, V2 is equal to bring this P2 to the denominator of the left side. So, the cross multiplication is a very important, students, here. So, we have to do carefully the cross multiplications here. So, P2 is equal to, we can write the P2 is equal to P1 V1 divided by P2, P1 V1 divided by P2. So V2 is equal to P1 V1 divided by P2. So in the problem they given the P1. What's the P1? 120. V1 0.4. P2 450. So they given the values. Substitute all the values in that formula. We will get the V2 in terms of meter cube. V2 in terms of meter cube. So we got the V2 as a 0.1067 meter cube. So in the problem they given that it is an isothermal process. So 1 to 2 is an isothermal process. At isothermal process, the constant temperature P1 V1 is equal to P2 V2. So all the terms are given in the data except V2. So we calculate the V2 by using this relation. We get the V2. Next, so the compression ratio. So compression ratio is R is equal to V1 by V2. R is equal to V1 by V2. So 0.4 divided by 0.1067 divided, we got the 3.75 as a compression ratio. The heat transferred during the compression, since 1 to 2 is an isothermal. So they ask the first bit, heat transfer during the compression. So during the compression means the isothermal. So dq is equal to dw. Dq is equal to dw. So whatever the work done is equal to is heat transfer, because the change in internal energy at constant temperature, change in internal energy is 0. So dq is equal to dw. So dw is equal to P1 V1 log R. So R is nothing but the compression ratio. It is given the compression V1 by V2. If the given it is an expansion, means we have to write V2 by V1. But in the problem they clearly mentioned that it is an a clearly mentioned it is an a compression. Clearly mentioned that the compression. The compression means R is equal to V1 by V2. If it is the expansion, R is equal to V2 by V1. So R is equal to V2 by V1. So calculate, we will get the work done during the heat, work done at constant work done during the compression process, compression during isothermal process. So here ln means nothing but log base E. Ln is nothing but the log base E. So we'll get as a 63.75 kilojoules, because we take the pressure in kilonewton per meter square. So W is equal to 120 into 0.4 into, here ln means log base E 3.75. So work done is equal to 63.75 kilojoules. The heat transferred during, so whatever the work is done in the isothermal process is equal to the heat transfer. Both are equal, because the internal energy is 0. Internal energy is 0 because both the temperatures are equal. T1 and T2 are equal. So anything into 0 is a 0. So here, according to the non-flow energy equation, dq is equal to du plus dw. Here the du is a 0 means, so dq is equal to dw. So dw during the compression process is P1 V1 log R. Log R means log base E. R is equal to V1 by V2. If it is an expansion ratio, it is a V2 by V1. But in the problem, they mentioned that it is a compression ratio V1 by V2. Next, and they given after that iso 1 to 2 is an isothermal compression process. They given it is an 2 to 3 is an adiabatic expansion process. Adiabatic expansion process 2 to 3. Here the two states are 2 to 3. So adiabatic relation becomes as a P2 V2 gamma is equal to P3 V3 gamma. So P2 V2 whole power gamma is equal to P3 V3 power gamma. So in this we know the P2 value, V2 value. We don't know the V3 and P3 value. We have to calculate. So P3 is equal to P2 by V2 by V3 whole power gamma. So P2 they given is a 450 and V3 is equal to V1. So 0. V2 already we got in the first bit. So 0.1067 divided by 0.4 whole power 1.4. Adiabatic index value 1.4. So we will get the P3 value in terms of kilonewton per meter square, because we take the 450 in a kilonewton per meter square. So P3 is equal to 70.75 kilonewton per meter square. Kilonewton per meter square. Calculate the work done during the adiabatic expansion process, where the adiabatic expansion process takes place between 2 to 3. So then the equation becomes P2 P2 V2 minus P3 V3 divided by gamma minus 1. So for the adiabatic process, here the process is 2 to 3. That's why we are writing as a numbers as a 2 to 3. If the process is from 1 to 2, we'll write the 1 P1 V1 minus P2 V2. Here the process is from 2 to 3 is an adiabatic process. That's why W is equal to P2 V2 minus P3 V3 by gamma minus 1. Gamma minus 1. So we have to substitute all the values. W is equal to, we know P2 value, and V2 we calculate that, P3 we calculate, V3 they given gamma minus 1. So we got the W as a 49.28 kilojoules, because we take the pressure in terms of a kilonewton per meter square. So it is in kilojoules. So next, non-flow energy equation, dq is equal to du plus, this is a small d capital U, not capital D small u, is it du, small d plus u, small d small d small d u small d u. So energy equation, dq is du, q is equal to w plus du. In adiabatic process, the heat transfer is a 0. Heat transfer is 0. So W is plus du is equal to 0. So change in internal energy during expansion, du is equal to minus W. So whatever the value you got is the negative sign of the internal energy. So here the internal energy is decreasing. Internal energy is decreasing. So negative sign indicates the decrease in internal energy. So this is the problem based on the adiabatic process. So first we have to read the question carefully and write what is the process they given. Here the both the process are the combination of an isothermal and adiabatic is there. So 1 to 2 it is an isothermal process, 2 to 3 is an adiabatic process. So 1 to 2 you have to apply the formulas of related to the isothermal process, and 2 to 3 process you have to apply the adiabatic expansion process. In isothermal the given is in a compression, isothermal compression, whereas in coming to the adiabatic it is expanded, adiabatic expanded process. So by using that formulas we can calculate the work done and the internal energy and the pressures and volume. This is the problem based on the adiabatic process. So we'll go to the next. Oh, so C bit is also there. You have to calculate the mass of the gas also. How will you calculate the mass of the gas? So here they given the Cp value and Cv value. So by using the relation, by using the specific heat gamma is equal to Cp by Cv, we will get the Cv value, and we know that R value also, Cp minus Cv is equal to 0.286. Next, P1 V1 is equal to MR T1. P1 V1 is equal to MR T1. So we know the P1 P value, V1 value. We have to calculate the M value. R value is this one. T1 value, you know. So I am writing this equation as a M is equal to P1 V1 by R T1. P1 V1 by R T1. So substitute all the values here, 120 into 0.4 divided by 0.286 into 298. So m value is equal to 0.563. M value is equal to 0.563. By using the ideal gas equation, PV is equal to MRT. P1 V1 is equal to MRT1. So we know all the values. P value, V value and T value, and R value we can calculate by using the Cp by Cv is equal to gamma, we will get Cv value, and R is equal to Cp minus Cv, we will get the R value here. Substitute here, we will get the mass of the gas. So an ideal gas initially at a temperature at 200 degrees centigrade and pressure 12 bar expands adiabatically to a pressure of 2.4 bar. Calculate the final temperature if the adiabatic index of the gas is 1. So read the question carefully and identify what is the process here. So expands adiabatical means adiabatic expansion process, expands adiabatically, expands adiabatically. An ideal gas, the temperature T1 200 plus 273 473 Kelvin, pressure 12 bar, so 12 into 100 1200 kilonewton per meter square, expands, so pressure 2.4. Here the pressure is decreasing, volume is increasing. Expands means the cylinder volume is increasing. When the volume of the cylinder is increases, automatically the pressure decreases because the pressure volume is inversely proportional to the pressure. That's why here 2.4 bar. Calculate the final temperature T2. That's the final temperature T2 if adiabatic index of the gas is 1. So the given adiabatic index gas value as a 1. Sorry, this I think it is a wrong. It's a 1.4. I will check once. P1 12 bar, T1 473 Kelvin, P2 2.4. We have to adiabatic index. It is in a 1.4. Not it is in a 1. Is a 1.4. 1.4 adiabatic index is a 1.4. And as the calculate the final temperature. So this problem is very easy. Just as the, if you know the relations between the P and T, you can easily find the final temperature also, final temperature. So write the given data, and it is an adiabatic process, and we know the for the adiabatic process the equation is expressed as a PV power gamma is equal to constant. So in the problem they given the relation, they given the values of a P and T only. So write the relations for the P and T. So we can write the equation T1 by T2 is equal to P1 by P2 whole power gamma minus 1 by gamma. So by using the relations of a T and P, by using the relations of a T and P, we will get write the relation T1 by T2 is equal to P1 by P2 whole power gamma minus 1 by gamma. So substitute the values here P1 and P2. So here both the P1 and P2 are in, they given in bar. So numerator and the denominator values are the same units. So continue like that only. T1 by T2 is equal to 12 divided by 2.4 whole power, the gamma value 1.4 minus 1 divided by 1.4. So it gives a ratio T1 by T2 is equal, we get one value T1 by T2 is equal to 1.584. Then the problem they given the T1 value, substitute the T1 value here, so we will get the T2 value here. So bring this T2 to the right hand side and this ratio value to the left hand side. So for 473 divided by T2 is equal to 1.583. So I am bringing this 1.583 into the left side. So 4.73 divided by 1.583 is equal to T2. So we'll get T2 as a 298.6 Kelvin. So if you want this put in a Kelvin or simply subtract with the 273, we'll get in terms of a degree centigrade. Is that 298.6 minus 273, so 25.6 degrees centigrade. So the final temperature is 25.6 degrees centigrade. So in the problem they given the values of a initial pressure, final pressure and initial temperature, and they asked to calculate the final temperature. So we all know the relations of a P, V and T, but in this problem we have to write the relations of a only T and P. So T1 by T2 is equal to P1 by P2 whole power gamma minus 1 by gamma is a relation between the temperature and the pressure, and substitute the data, whatever the data given, substitute in the relation, we will get the final temperature in Kelvin. So if you want to convert into the degree centigrade, simply subtract the answer with a 273 degrees centigrade, we will get as a 25.6 degrees centigrade. So this is the another problem based on the pressure and temperature relation. So move on to the next. 1 kg of air is compressed adiabatically so that the pressure increases from 1 bar to 10 bar. The work is 200 kilojoules is done on the air. Calculate the initial and the final temperatures of air assuming CV value 0.718 kilojoule per kg Kelvin and gamma 1.4. So here they given is a compressed adiabatically. Compressed adiabatically means the work done is nothing but the P2 V2 minus P1 V1 divided by gamma minus 1. So first we have to identify what process is this. Is it clearly mentioned? It is in a compressed adiabatically. Compressed adiabatically. Mass 1 kg. So the pressure is increases. Pressure increases means volume is automatically decreases. P is equal to 1 bar and P2 is equal to 10 bar, and work done is 200 kilojoules. And here they given it is a compressed adiabatically means you have to take is a negative value minus 200 kilojoules. Calculate initial and final temperatures. So T1 and T2 have to calculate CV value, gamma value. So by using these two values we can calculate the CP value and R value also. And for the adiabatic process the heat transfer Q is equal to 0. Heat transfer Q is equal to 0. So mass of the air M 1 kg, initial pressure 1 bar, final pressure P2 10 bar. The work done is a minus 200 is a very important here, because if they given it is compressed adiabatically means work done is a negative. Work done negative means internal energy is increasing. For the adiabatic process, what is the condition? The net heat transfer is a 0. Q is equal to, so dq is equal to W plus U2 minus U1. So 0 minus 200 plus U2 minus U1. So U2 minus U1 is equal to 200. So U2 minus U1 is equal to 200. So we know that U2 minus U1 we can also write as an MCV T2 minus T1. So MCV T2 minus T1 is equal to 200. Substitute the values of a MCV value, and you got the some difference of a temperature is equal to some value. I am putting this equation as a 1. T2 minus T1 is equal to 278.58. So for the adiabatic process, the net flow non-flow energy equation dq is equal to du plus dw. Here the heat transfer dq is equal to 0. So if the work done given is a compression process, so minus 200 plus u2 minus u1. So u2 minus change in internal energy is equal to 200. We know that the change in internal energy we can write as a mcv t2 minus t1. So in the problem they given the value of a m value, cv value. So we get the one equation of the temperature difference as a 278.5. I putting the equation as a 1. Now I am using the relation of a temperature and the pressure. So we know that the T1 by T2 is equal to P1 by P2 whole power gamma minus 1 by gamma. So in the problem they given the values of a P1 and P2, and we know the gamma value. So by using this equation we will get another equation T1 by T2 is equal to 1 constant. So by using these two equations, solving the two equations, we will get the temperatures T1 and T1 and T2. So T1 by T2 is equal to 1 by 10 whole power 1.4 minus 1 divided by 1.4. So T1 by T2 is equal to 0.51797. So I am writing T1 is equal to 0.51797 T2. So I am substituting this second equation in the first equation and simplifying, we will get the T1 and T2 values, T1 and T2 values. So by using these two equations, our T1 minus T2 we got one value, T1 by T2 another value. These are the two equations, and by doing the calculations, we were simplifying, we get the T1 and T2. If you want to convert into the degree centigrade, simply subtract the answer with the 273, we will get in terms of a degree centigrade values. So moving to the next problem. So it is a next problem. 0.12 meter cube of air at 1.5 megapascals and 1500 degrees centigrade expands adiabatically to 175 kilopascals. Calculate final temperature and the work done, Cp value and Cv value. So first read the question carefully and highlight what the process it is. So it is a expands adiabatically process, expands adiabatically. So volume 0.12 meter cube of air means the pressure 1.5 megapascals, temperature 1500 plus 273 1773 Kelvin to 175 kilopascals. Calculate the final temperature T2 and the work done, and the Cp values, Cv values given. By using the Cp and Cv values, we can calculate the gamma and R value also. We can calculate the gamma and R value also. First write the given data. Initial conditions. So P1 1.5 megapascals. I am converting into the kilo. So we know that mega means 10 power 6. So I am just converting into the kilo. So I am writing only 10 power 3. So 1.5 into 10 power 3 is a 1500 kilopascals. T1 1500 degrees centigrade. V1 0.12 meter cube. Final conditions. P2 175 kilopascals. T2. Next, adiabatic index gamma. Gamma is equal to Cp by Cv. Gamma is equal to Cp by Cv value. So, they given the values of a Cp value and Cv value, we will get 1.4. Gamma is equal to 1.4 and R to Cp by Cv. For adiabatic process, T1 by T2 is equal to P1 by P2 whole power gamma minus 1. So substitute the values of P1 and P2 they given 1500, 175. So we will get T1 by T2 as a 1.8474. And we want final temperature. Final temperature means we know the T1. T1 they given in the problem. Substitute there, we get T2 is equal to 1773 by 1.8474. So we will get the final temperature. So after getting the final temperature, if you want in degrees centigrade, simply minus 273 we will get in degrees centigrade. So first write the whatever the given data, initial conditions and the final conditions, and the right there's the calculate the final temperature. Final temperature means you know the relations between the pressure and temperature. So pressure and temperature means T1 by T2 is equal to P1 by P2 whole power gamma minus 1 by gamma. So in the problem they mentioned, they given the P1 and P2 and T1 values. Substituting all the values here, we will get the T2 value. Next we have to calculate the work done. So in the problem they given it in expands adiabatically. So the expression for the work done during the adiabatic expansion is P1 V1 minus P2 V2 by gamma minus 1. So in this formula we know P1 value, V1 value, P2 value, V2 value we don't know the V2 value. So first we have to calculate the V2 value. How will you calculate the V2 value? By using the relations of a pressure and volume or volume and temperature. We can use anything because we know that temperature T1 and T2. So by using the pressure and volume relation or volume and temperature. We can use any relation. Here I am using the pressure and volume relations. So students, you try with the temperature and volume relations. Temperature and volume relations. So what is the temperature and the volume relations? T1 by T2 is equal to V2 by V1 by gamma minus 1. So students try with this equation to calculate the T1. Here I am trying with the PV relations. You try with these relations. So both the values should be same. So T1 by T2 is equal to, or T1 by T2 is equal to V2 by V1 whole power gamma minus 1. V2 divided by V1 whole power gamma minus 1. So you know the values of a T1 and T2. V2 we have to calculate, V1 we know. Gamma 1.4 minus 1. So calculate the V2. We'll get here I am using the P1 V1 power gamma is equal to P2 V2 whole power gamma. So here the we know P1 value, V1 value, P2 value. We have to find V2 value. So P1 by P2 is equal to V2 by V1 whole power gamma. So P1 1500 divided by 175, V2 by V1. I am bringing this 1.4 to this side. I am bringing this 1.4 to this side. So 1.4 power comes to this side, left hand side, it becomes as a 1 divided by 1.4. By simplifying, we will get the 0.5567 meter cube. So V2 is equal to 0.5567 meter cube. So by using the temperature volume relation also, we will get the same answer. V2 is equal to 0.5567 meter cube. So in the problem they asked to calculate the work done. So work done during the adiabatic expansion. Adiabatic expansion is P1 V1 minus P2 V2 divided by gamma minus 1, or MR T1 minus T2, MR T1 by T2 gamma minus 1. So I am using the relation P1 V1 minus P2 V2 by gamma minus 1. Students, you can do this also. So we will get the same answer. We will get the same answer. MR T2 T1, sorry, expansion, no, T1 minus T2 T2 gamma minus 1. So W equal to. So you can use this equation also. So R value can find by using Cp minus Cv. Cp you can calculate by using Cp minus Cv. T1 you know, T2 calculated. So gamma 1.4 minus 1. So here I am using this equation P1 V1 minus P2 V2 by gamma minus 1. So P1 value, V1 value, and P2 V2 1.4 minus 1 we will get as a 206.44 kilojoules. So work done is equal to work done during the adiabatic expansion is a 206.44 kilojoules. So these are the problems related to the adiabatic compression and adiabatic expansion process. So in these mainly two formulas are there. One is the expression for the work done during the expansion process and the compression process, and the relation between the pressure, volume and temperature. So once again I am telling the formulas. So work done during the expansion process, P1 V1 minus P2 V2 by gamma minus 1, or MR T1 minus T2 by gamma minus 1, or reverse during the compression process the work done is P2 V2 minus P1 V1 by gamma minus 1, or MR T2 minus T1 by gamma minus 1. So relation between P and V. So I am telling the combined equation. So V2 by V1 whole power gamma is equal to P1 by P2 equal to T1 by T2 whole power gamma by gamma minus 1. So these are the formulas based on the adiabatic process. In the next class, we will discuss about the polytropic process. Polytropic process. Till now, in the second chapter, thermodynamic process, we completed the 5 process. So first one is a constant pressure process, constant volume process, isothermal process, next adiabatic process. So the next one is a polytropic process. After that polytropic process, we will discuss about the throttling and free throttling process and the entropy, throttling and free expansion process. So with this total 7 processes are there. So in the two more classes there to complete this process. After that we will do whole problems based on the constant pressure, volume, temperature. So combination of isothermal, adiabatic and the polytropic process. We will discuss about the polytropic process and some problems also based on the polytropic process. Thank you.